I don't know if Devin's going to be here or not. He might be doing his map testing thing. So natural progression of where we're at. Sorry. I didn't get a chance to eat all these last hour. I'd like to think that we've kind of turned the corner on the level of difficulty of things that we've done throughout the semester. Yeah. What's that? No. We have about a week left of trig, and I know everybody's really sad. No. That's why I broke it up this section. Nope. Nope. Guys, question was, will we have a giant test on everything? Could you imagine how awful that would be? It would like be having a secondary final. So I will say one thing, the final is what's going to have the majority of all that put together. Because when you break down second semester stuff, half the semester really does incorporate trig. And everything else goes from there. So what we've got left to do is just graphing. And the graphing stuff, I usually take 4, no more than 5 days to get through. 5 days is probably about the max. I've seen this the first hour also, is that I know right now that a week from tomorrow, I'll be here, but I won't be here. We have, we're working on, remember first semester we had a day where all the geometry teachers were out, we were building up our new final and stuff like that, because of the new curriculum, new materials and everything. They gave us, the administration gave us that day again for second semester, which kind of makes sense. So we don't have, so we have a day to kind of put everything together. So I'll be here, but I just won't be here. It won't be a big deal. I think by then we'll be pretty much done. So if worst comes to worst, we might be quizzing that day while I'm not here anyway, and just do that. It kind of might work out nicely. The way that I've always approached graphing is that, again, this is still the non-calculator stuff, and it's much easier to do this non-calculator with. What we're going to look at here is stuff like this. The easiest thing to start graphing with is to look at your quadrantals. And I know we've kind of briefly discussed this a while ago. When you talk about the ordered pairs that are on the quadrantal, what's the ordered pair on the right at 0? It's 1, 0. If I go up at 90, I'm at 180, and then 0, negative 1. And then what we started to do is we started to talk about them in terms of their ordered pairs. And when I look at them in terms of ordered pairs, we're talking about x values and y values. But in terms of trig, what are we really talking about? Sines and cosines, but what comes first? Cosine. So cosine always deals with your x value. Sine always deals with your y value. Now, when I graph these things, I've always thought that it was easier to show you guys what a sine graph looks like first, because then a cosine graph is the same thing, just shifted 90 degrees. Let me show you what I mean. When I look at a sine graph, I'm looking at the idea of, we start at 0. If we go full circle, you start at 0, you go all the way around, and you end at, we don't call it 0, but we call it 1 full revolution, puts me at 2 pi. Very good. Okay. What is halfway between 0 and 2 pi? Pi. Good. What's halfway between 0 and pi? Pi over 2. Then what's halfway between pi and 2 pi? Wrong. There are no blueberries in this, but it would be 3 pi over 2. Does the value of sine, or let me rephrase that, is the value of sine ever greater than 1? Is the value of sine ever lower than 1? less than 1. Okay? The value of sine never goes past 1. It never goes below 1. And there's reasons because of that, and we'll write this out here in a second. So what we do is we look at this graph of y equals sine of x, where we're taking values of x, substituting in values for x to generate a value of y. So what is my value of sine at 0? 0. What's the value of sine at pi over 2? What's the value of sine at pi? 0. Bless you. At 3 pi over 2 is. And then back at 2 pi you're at. So sine does that. We did. I was just showing you guys kind of where everything was going for. Where everything was going to. Yeah.
Can you go over that?
We will. Okay. Now, the idea here is that your value of sine he's just an idiot. Just if you don't pay attention, he just might give up. Sorry if that hurt. I didn't mean it to make it hurt for me, did I? So your value. I'm sorry. Hey, here, error 5 to make up for it. Shimky, help me out. Shimky, yours is the. That's better. See, I feel better now. Watch what happens when you work with cosine. If I use the same graph, cosine, when you substitute in 0 for x, what's cosine of 0? 1. Cosine at 0 is 1. Cosine at pi over 2 is 0. Cosine at pi, it's -1. Back to 0. Back to 2. Back to 1. So the cosine graph and the sine graph technically are the same curve. They're just moved. Watch what happens. It's the same graph. It's just moved over 90 degrees. They're the same curve. Okay. Now, what happens here is that you get, depending upon which trig function you're using, it'll start and stop at different spots. And that's where the idea of this, what we call a generic form, or better yet, a parent function of graphs comes into play. Now, will this graph just continually just oscillate and oscillate and oscillate? Now, if you guys have had physics, that's kind of like a sound wave. Sound waves oscillate. The longer it takes to oscillate one up and down, the lower the pitch, the quicker it oscillates, the higher the pitch. And then, is this volume? The frequency when it goes up and down, is it? I don't know. Pitch. Most call it pitch. I think it's. No, pitch would be high pitch, low pitch. Whatever, anyway. So, I don't know. I don't remember. I took physics, I was really good at it, but I forgot it. So, this value up would be called an amplitude. The time it takes to fill in one full oscillation is called its period. The time it takes to go one full oscillation would be a period. These sines and cosines are what we call periodic functions. They repeat themselves after so much time frame. They just go over and over and over again. Okay. So what's going to happen here is this. We're going to get this generic idea of y equals a sine bx and y equals a cosine b of x. Where these values of a's and b's will help us to determine what's called amplitude and period. And it's really, really easy to work with. For both of these, this value of a is what it tells you if it's positive. Well, it tells direction. And then the absolute value of a is what's called the amplitude. Bless you. Okay. The absolute value of a tells the amplitude. When we go back and look at your quick graph of sine. Sine started at 0, it went to 1, back to 0, -1, back to 0. Sine always starts at 0, it goes to its a value. Cosine always starts at a value, it goes to 0, and so on. I'll write all this stuff out here. That's how you're able to tell the difference between sines and cosines, and that's why you know when we start writing ordered pairs out, if you're doing things correctly, if your sines, S-I-G-N, start oscillating as we get into this more. This value of b. This b value is kind of like a multiplier. It helps to find the period. The period of both sine and cosine is always going to be the same thing. The period will always equal 2 pi over the absolute value of b. Now I write it as the absolute value of b, but I don't think you're ever going to see a negative b value in algebra 2. It doesn't really make a big deal. The b value doesn't do anything else. You just know that your period would be the absolute value of it. Okay? The a value can be negative. If sine was negative, instead of going up, you go down. You just go the opposite directions. That's really all it means for a's and b's. Okay? Oh. Better, now you can flick away. Sloth was doing math. Yeah, he was huffing the aerosol. He was huffing the aerosol. Don't huff aerosol. Your eyes go like this. Top tip.
Always sad. I'm always sad when I don't eat. Maybe it'll be worse than you think.
Here.
There you go. See, gangs make you happy.
Is that better?
Yes. The gangs make you happy.
Or I should transpose that picture of Mr. Fontana's face onto it.
Sure. Perfect.
Challenge accepted.
Tomorrow.
Let's go right into what we call a parent function. Notice I keep using this word parent function, which means what are we going to do to it in a day or so? And if we shift something, what are we going to bring back? HGK. I'm crazy, but I like my job. I mean, if you hit me first. So here's what we do. I always start by listing out what A is, what B is, and then I go, what's my amplitude, and then what's my period. After we get into the shifting stuff, which we probably will get to tomorrow. So far today, we got through this relatively easily first hour, and so far you guys are like, so I don't think it's gonna be a problem to start shifting right away tomorrow. What I usually do is I'll do the sines and cosines, parents, and then shifts, and then I'll do tangents all on its own. Tangents are a little bit weird because they're non-periodic. They have, remember how they have asymptotes at 90 degrees? So they're gonna have asymptotes we'll have to mess around with. Their periods are a little bit different. The way that they graph out are a little bit different, but it's again, it will be really easy to work with. So if I start with this, what's your value of A? -2, good. So my value of A is -2, which means my amplitude will be 2. My value of B is 4. That means my period will be 2 pi divided by 4, otherwise known as, what was that? Pi over 2, very good. So, every one of these problems is going to look the same. You're always going to draw the sideways t-chart. You start with 0. You end with your period. And then you ask, what's half of a half? You have pi over 4. What's half of a fourth? An eighth. Good. Now, if you watch what's happening here, 0, 1/8, 2/8, and then 4/8. So this would be 3 pi over 8. You were saying yes. I said 4/8 would be 1/2. You're right, Nina. Don't have to talk away. Okay. So your fractions that you're working with, I mean, even if your period was pi over 8, what's half of an 8? What's half of a 16? So 1 32nd, 2 32nd, 3 32nds, 4 32nds. By doing this breakdown of the period like this, you're breaking it into fourths, just like we did with the unit circle. Start at 0, end at 2 pi. What's half? Pi. What's half? You're broken into fourths. You're doing the same thing. Okay? Your A value is -2, so you have to go up 2 and down 2. Sine. Sine always starts at 0. Let me write this out for you so you remember. Sine starts at 0, goes to A, goes back to 0, and then goes to the opposite of A, and then goes back to 0. Your parent function of sine will always do that. It does not matter what the value of A is. The value of A is just going to help you to determine what direction do you go. Do you go up first or down first? In this case, I'm going to go which way first? Which is it? Down. The reason I have to go down first is because it's the A values thing. So I start at 0. I go to -2, back to 0, +2, and back to 0. And there's your curve. Yes. What'll happen as we start to shift these things, you'll see the reason why I label out all of my periods and stuff like that, because we will start to write out ordered pairs. And we put them in order. Yeah, but it's super easy. Because a lot of times your shifted fractions, you'll have to add pi to it. So if I'm adding pi to pi over 8, I'm going to add 8/8. So 8/8 and 1/8 would be a 9/8. 4/4 and 1/4 would be 5/4, and so on and so on. So it's really, really easy when we start working with the fractions. You're not going to have to worry about shifting 3/7 to a 1/8 and trying to get common denominators with 56. No, you're not doing stuff like that. Okay? That sounds awful. You're right. I don't want to do that. But your fractions you're working with, you'll have a lot of eighths and halves and quarters and sixteenths and stuff like that. They're not going to be awful. So what we'll do tomorrow is we'll list out all the ordered pairs, and then you're working with H's and K's. H's move things which direction? Horizontally, left and right. So is that your X or Y values? Your X values. Your vertical values go up and down. So what will happen is you'll have some X plus some H or Y plus some K, and you'll just do it ordered pairwise. again, it's going to be really, really easy because every single problem always starts exactly the same. What is A? What is B? What's your amplitude? What's your period? It's nice that we get into something that's, I don't know what to do next. Oh, you factor out a cosine. Oh, okay. No, you do this. So it works out cleanly. Try another one. Say we have y equals 1/3 cosine of pi over 2x. Absolutely, you can move wherever you want. You can go to the next price if you want. You can sit over here. Poor Peyton's all by himself. I don't blame him. He smells funny. I mean, actually, he smells a lot better than what Peyton does because. There's no room. No. Again, what do you think you have to do first? Nothing. Well, you want to do something. How do you divide by a fraction? So if I multiply by the reciprocal, what's 2 pi times 2 over pi? 4. So your period in this case is 4. Is it okay to have 4 for a period? Absolutely. Because what's happening is that value of b is a multiplier to some value of x. Okay? It's not a big deal. So you start by drawing it out, your sideways t-chart. We start at 0, we end at 4. This is real tough. Seth, bear with it. I think you can do this one. Half of 4.
3.
I didn't mean to put you on the spot. It's actually 2, but you can continue to try. He's laughing at me. That's okay. So what's half of 2? Shut up.
Yes.
1.
No.
So my A value is 1/3. So all I have to do is mark off a third up and a negative 1/3 down below. It doesn't have to be scaled, guys. This is just visual representation of what it is. Okay. Cosine graph. Where does it start? It starts at 0 or A? A. That's right. So what's your value of A? Set myself up for that one. E 1/3. It goes 1/3, 0, negative 1/3, 0, and 1/3. What do you mean?
Y equals cos x, y equals cos b, cosine b. Is there an x equals cosine b? Cos b? You don't get it?
I know that the sine of b divided by the tangent of b is cos b. Please save me. It would start at negative 1/3 and go up. So cosine graphs, I'll write this out also. Cosines, they start at A, 0, opposite of A, 0, and A. Cosine graphs always do that. I should say cosine parent function graphs always start that. Yep. So then it would start if your A value in this case was negative 1/3, you'd start at negative 1/3, go to 0, opposite of negative is 1/3, and so on and so on. All right. Do one more. Yep. You do this one, because I don't want to. You'll be fine. With any luck. Bless you. You guys get a period of 3 halves? Okay. 3 halves for the period? So, we now know cosine. We start at 0. We end at 3 halves. So what's half of 3 halves? 3/4. Very good. Half of 3/4 would be 3/8. So now if you start thinking about it, what you're doing is you're adding by eighths. You have 3/8, 6/8, 9/8, and that would have been 12/8. So this is 9/8. Okay? And because you haven't done fractions like this in a long time. Now, one of the things that you guys will notice is that obviously the period where it ends is going to be simplified. Where it starts is going to be your common denominator. That'll be the smallest unit. So if you know that everything's going to have to be in terms of eighths, that's an easy way of thinking about it. Okay? That's about as tricky as most of this stuff gets. So now you know that your A value was 3/4, so here's 3/4, sorry, negative 3/4, excuse me. Cosine. Does cosine start at 0 or A? Hey! This is going to get old real quick. So, so what is your A value? All right, so I start at negative 3/4. I go to 0. I'm gonna do more sine graphs than cosine graphs because there's less A's. Did you go the wrong way?
Yeah.
Just turn your paper upside down and be fine.
I forgot the negative.
Tomorrow, what do you think you're gonna do when you put a parent function on there to connect the dots? We will dot parent graphs, and then we will solid the actual real thingamajiggies. Oh, I didn't do one problem. Let's write a positive sine equation that has an amplitude of 10 and a period equal to 4. Reason I had to say positive sine equations because your A value could have been positive or negative. In the textbook, it'll say, I think it says a positive equation, so I just forgot to write that in there. So what we're looking at here today is you want to write a sine equation that has an amplitude of 10 and a period of 4. So that means your A value is what? 10. Your period for sine is equal to what over what? So this equals 2 pi over b, which means what are you trying to solve for? B. So when you have fraction equal fraction, or so in this case here, to make it even easier, can I just do the good old-fashioned exchange-o? If I exchange-o here, I get b is 2 pi over 4, which is Nina, you're not wrong. Cross multiply and divide. If I cross multiply, I get 4b equals 2 pi. 2 pi divided by 4 is still pi over 2. Okay. So that gives you all your information. Well, I lost you. What's wrong? which means I know that I have y equals a sine bx. So y is 10 sine pi over 2. Get it done. Do those. I posted already in section 14.1, 26 through 48 evens, but I need you guys to make sure you skip anything that says tangent, because you don't know how to do them yet. So it's kind of difficult to know how to do on a tangent. I believe the first couple, the first cosine, and the sine graph, it was asking you to find out what is the amplitude and the period of those first three. So if you just want to take a picture of it, these were what's the amplitude and period for 26, 30, and 28. These guys are the ones that you're graphing, and then here you're writing equations. Okay. Again, notice how I said that A is positive, B is positive. So that's kind of what I was getting at. Write a positive sign equation. No, it's really easy. This should not take you more than about 10, 15 minutes. Yes, sir.